Okay, we're going to take a look at a lifetime annuity. So this is a case where we're going to get a regular payment, and this regular payment is going to come forever. So this is different from the other questions we've been seeing, because in all of our other questions, that was done for a set amount of time, 10 years, 20 years, 8 years, some set numbers of years. We want to set up for an unlimited number of years, that we would be getting $3,000 per month forever. And just for quick background, we need some information here. So just for convenience, I went ahead and picked, let's see, well, M, because we're getting monthly payments, 12 months in a year, M is going to be 12. And then as an interest rate, I went ahead and picked 4%. Nothing magical in my choice of interest rate. I just needed to pick one. And what this scenario is actually comparable to is a case where we're looking at an endowment, where a set amount of money is deposited or invested, and the only thing that ever gets withdrawn from that is the interest. So our present value here is going to represent the endowment. We want to live off the interest, which means that we need our monthly interest to equal $3,000. So kind of the challenge of this is figuring out how we can use our template to do this, because again, we want to stay away from getting too mathy on it. And if we head on over to our template, what we really want to have in this scenario, or I'll do this over here. So after 1 month, we want $3,000 more money. So we want our future value to equal however much we deposited plus $3,000. Now, I already went ahead and put in the other information here. So 4% interest, there's 12 months in a year, and we only need to look at 1 month, and that's what this 0.083 repeating represents. It is decimal version of 1/12. Now, what I struggled with during class time is figuring out how do I set this up using either GoalSeek or Solver. And naturally, as soon as everybody clicked off, it immediately came back to me what I needed to do. So when we're doing this, we either need to, if we're going to use Solver, we're either going to need to maximize something, minimize something, or set it equal to some fixed value. If we're going to use GoalSeek, we have to use a formula where we're only going to change one value. And the only thing that we want to change is the present value. We want to know what that lump sum is. And what I forgot about here is the way that I could get us to keying in on a single value is if I took the formula future value for periodic compounding, and I subtracted the new one that I just did. If this is equal to 0, so if I do that minus that, So right now they differ by 3,000. Now, if I start changing the value in the present value, every time that number changes, my formula is going to change down here. Now I'm in a scenario where I can use goal seek. So it's this little, the difference between those two cases. That's what I needed to use. And again, this first one here, this formula here is merely present value plus the $3,000 of interest we want to earn. So data, goal seek. So I want to set this cell and I want it to be 0. And I want to do that by changing my present value. So in this scenario, we're going to have to deposit $900,000. If we deposit $900,000 and we're earning 4% APR, then at the end of every month, we're going to have $3,000 of interest. So we can go ahead, take that $3,000 of interest as our payment. That takes the balance back to $900,000, and in the next month, it'll earn another $3,000, and it will continue to do this, at least in theory, forever. As long as we're getting an APR of 4%, this principal amount is going to generate an income of $3,000 a month forever.